Hello, in this video we're going to talk about file operations or file input outputs. Okay, so just as a motivation, think about most of the programs that we wrote up to this point. Once we run it, once we do something, and then the program terminates, the next time we start it, it's going to start all over again, right? That's because anything that it does, it is only kept in the memory. It has nothing that is actually persistent. So everything every program that we wrote so far, whatever they do, it's temporary. Now, it works okay, but imagine in the real world, let's say a smartphone that can only take pictures, but it doesn't remember any of them. So once you turn off the phone, all the pictures are gone. Or Facebook or Twitter or whatever, that just don't remember any of your posts, any of your likes, any of your activities. That's not a very fun or useful service or a smartphone for that matter, right? So most real world devices or applications have persistent memory. So file is a way for a program to keep things around for a long time, even after it terminates. So that's a motivation to study files. Now, just like a variable that we can read and write to a variable, a file, we have to be able to read and write to it. So reading a file is actually a more frequent operation. So let's start with reading a file. So I've said that everything in Python is an object. So file can also be represented by an object. And in order to obtain an object that represents a file to be read, here's what we do in the code. So we start with the file name. So the file name is called poem.txt. In this case, this is just a kid's poem that I found, and that's the file. So in order to open that file, we say open and the name of the file. And open returns an object. Technically it's a file object. I'm going to call it a file object, even though technically it's called a stream object. So anyway, so it opens the file and we return this object that represents the file. Now we can run this and we can see, file. It says the type is a text IO wrapper. Don't worry about exactly what it is. It's a file that we can further manipulate. It's got a name, poem.txt. That's what we just opened, and the mode is R. R means read. Encoding UTF-8, we've seen that before. So, all right. So now we have something that a file that we can work with. What can we do? Well, we can read from it. To read from a file, it's really kind of simple in Python. Well, let's not worry about close yet. We can just say for every line in the file. So this is using a for loop to read the file. There are other ways to read from the file, but let's use a for loop that reads the file line by line. Okay, so let's read a line in and then print it out. So let's run this. All right, so look at what we print out. And remember the poem. The poem is now we're 6, when I was 1, when I was 2, when I was 3, and so on. So look at what it actually prints out. When I was 1, when I was 2, when I was 3, so on. So basically every single line, it reads every single line and print it out all the way until the end, source. And that's source, that where the poem comes from. Yeah, so that's that. That's how you read the file and line by line. Okay, now one thing you probably notice is, why are there all these extra new lines? Well, so the way this for loop works is it reads line gets us each time around the loop, line gets assigned everything up to the new line character, up to and including the new line character. Okay, so now, and coupled with the fact that print also insert a new line at the end automatically every time. So that's why we have an extra new line here. So if we don't like that extra new line, what we can do is we can strip it out, or we can change the separator to nothing. By default, it's a new line, but now we don't want that new line anymore. So, oh, not the separator, the end. There. Okay. Yeah, I think that's what these two slides are trying to say. Okay, now another very important thing about opening a file is that the file object returned by open, it actually holds what's called system level resources. Now these system resources are very precious, so they must be released when we no longer hold them. Right? Okay, so this is really important, especially when the program actually runs for a long time. Not the programs that were written so far, but for things like web servers, which just runs for days, weeks, even months. These programs will open lots of files. So if they don't close them when the files are no longer needed, then the system may run out of these file resources. And when the system runs out of resources, it will kill the program to reclaim those resources. So it's very important for us that once we are done with the file that we've opened, we should close it. And to close a file, as you already see, you basically just go reference the file, but dereference the object that represents the file and do a close on it. Okay. Now, obviously, when we run it, it's not going to make any difference. But again, it's important to close the file when we're done with it. This is important. Now, once you close a file, you can no longer read from it or access it at all. So if I do a close here and then I try to read from it again, guess what happens? Well, I can no longer do that because it says I'm trying to read on a file that's already closed. So this is not going to work. Okay. Next thing. Now our file example here is very simple. Right? It consists of opening a file, just read all the lines and then print them out and then close it. Now in the real world, oftentimes it's not so straightforward. Many times between opening and closing a file, other things can happen. And sometimes those things can cause the program not to reach the line where we close the file. And as we already said, if we don't close a file properly when we're done, it's a serious bug. It's a resource leak. So it's been for a long time. It's been a burden on the programmer to have to make sure to be able to close all the files that it opens. And like I said, it's actually harder than it seems. Now it's such an important thing to close the file that Python actually has a construct that specifically designed so that will ensure a file is always closed. And that is with literally the with keyword. So let me show you how this works. I think I can take this out now. So, well, or not. How this works is instead of using this line to open a file, I literally say with open a file, and when I open this file, whatever open returns, I'm going to assign it to F. And I am going to put anything that I will do with F inside the with block. So the with line actually creates a block of file. I mean, a block of code. Okay. Now, and the important thing is, even though I did not say f dot close here, the magic of the with keyword is that when I exit this block of code, when I reach the end of this block of code, f.close is automatically called all the time. Okay, so now if I run this, it shouldn't make any difference. Okay. Yes, and one thing I want to mention is, yeah, so again, yeah, Python guarantees to call f.close when this block of code is done. Okay, now if you have studied exceptions before, or in other languages like Java, you might have heard of like the finally keyword that guarantees to execute certain block of code. But using the with is even better than using the finally, because it's just so much cleaner, right? This just looks very clean. So, okay, to prove to you that the when we exit the block of code inside with, the file is actually closed. Let me show you this. So there is a way to check if f is closed or not, and that is actually access the dot closed attribute. So inside the with block, when I check if f.close is true or not, it should be false, right? Because at this point, we just open the file and we can, do things with the file. After I exit a block of code, when I check closed, it should be true, right? Because I exit the with block. So let's run this and make sure that's the case. And look at this. So inside the with, close is false. It's not closed, but once we are outside out of the with, then closed is true. Because again, when we exit the block of code, f.close is automatically called. All right.